okay? So we're gonna find the velocity of the ball using this. I'm gonna give you the mass of the ball. The mass of the ball should be something like 16 grams. The mass of the tube is something like 118 grams, all right? The only problem now is the final velocity. So we're gonna use an equation that you guys are familiar with. We just did it in the last experiment, 2 experiments back. And we're going to use this equation. I'll probably talk about it later. 2 times G times Y final, okay? So we derived this one from the conservation of energy. Conservation of energy. So we have our video in there. Let's look at our calculator. And we know it's already downloaded. All right, so you'll see that the only real thing that we're going to need is this y here. And you'll see we have our initial velocity. Initial velocity is going to be calculated using the conservation of momentum and the conservation of energy laws. And then we're going to replace this with the kinematic theory, the initial velocity that we found using kinematic theory. So let's go ahead and share this with Microsoft Excel. And then we'll start with our data collection. Sure that it wasn't going to open there. So I'm just now opening up Microsoft Excel. It was earlier, but I deleted it. Well, I closed it, not deleted it, but I closed it. So it's going to open up well here, and let's make sure that we put this into the right folder. We're in the ballistic pendulum. So let me change this, and let's call this the let's call this the CON calculator. All right, so we can see this pretty clearly. We're going to put our data points in here. We still have our displacement that's going to be calculated. We're going to find our average displacement. We're going to put this into, well, that's going to go into this formula here. So you see we have our 16 grams plus our 118 grams divided by 16 times the square root of 2 times 9.8 times the height of the ballistic pendulum. And that's going directly back to our law here. So we have this velocity here. Once we're done with this velocity, we're just going to put it into this equation right here. So you see this velocity. So we can just put those two together. We'll get, and I'll just write it. We'll get our initial velocity equals to the mass of the ball plus the mass of the tube over the mass of the ball times 2 times G times Y sub F. This is the equation that we're using in Microsoft Excel. All right, we're going to use video physics to find Y sub F. So let's just go ahead and go to video physics. And it should be, oh, so it did load up. Let's go ahead and change this to COM. What are we going to call this? COM. Yeah, that'll be good. Conservation of momentum. So I'll just go into that particular file. I'm going to go to our origin and scale here. Let's set our origin on this anchor bolt. So basically I have an anchor bolt here I have some fish line. You can kind of see it, and I have a fish hook here, and I'm going to track this anchor bolt. So this is the 0, 0 point. Of course, you could pick something different. And let's just pull this down. I'm going to set my scale to 0.1. Let's go ahead and take a snapshot of that. Let's just upload this to Dropbox. Is not open, but it should be in this folder already. Yep, there it is. Let's just upload our snapshot. And of course, we're going to change the name to something readable, as opposed to just writing stuff in there. So now we have